Jai Hind students, welcome back to the second video of today's mathematics class. Hope all of you understood the concept of the first video class and all of you understood the relation between coefficients and zeros of a polynomial.
Yes, now we are going to see some examples on the relation between coefficients and the zeros. Okay, come to the first question. Our first question is find the zeros of the polynomial 4y square minus 3 minus 4y and verify the relationship between the zeros and coefficients. So what is the meaning of the question? We need to find out the zeros of this given polynomial. Here you can see this is a quadratic polynomial, and then you need to verify the relation between those zeros and coefficients of the given polynomial. So first we can write what is the given polynomial here. So our solution, yes, given our polynomial is 4y square minus 3 minus 4y. Now you see children, here this polynomial is not arranged in the standard form. You know that when you arrange, first we need to write 4y square, then the y term, then the constant term. So before going to the solution, you need to arrange this in the proper form, that is 4y square minus 4y then minus 3. Okay, so first we need to arrange the polynomial. Now you want to find the zeros of this quadratic polynomial. As you know, to find the zeros, we are going to apply the splitting the middle term method. So what is the zeros we can check. So 4y square, to find the zeros what you will do, equate the polynomial to 0. So 4y square minus 4y minus 3 equal to 0. Now we are going to find the zeros. So you know that product value, what is the product value? 4 is here, coefficient of y square. So here 4 into minus 3, minus 12 is the product value and the sum is minus 4. So what are the two numbers that will give you the sum, product minus 12 and sum is minus 4? Product 12 means you know that 2 6 are 12. So to get minus 4 as the sum, we need to take the negative of minus 6 and plus 2. So minus 6 and plus 2 will give you the sum minus 4 and product minus 12. So using these two numbers, we are going to split the middle term. So this implies 4y square minus 6y plus 2y minus 3 equal to 0. Now we need to pair the terms and find the value of y. First two terms, 4y square minus 6y from 2y is common. So the remaining is, you know, 4y square. So 2 into 2, 4. So that here 2y minus 6 need to come. So 2 into 3, 6. 2y minus 3, and from here you see 2y minus 3, the second pair, here no common factor, so you need to take 1. When there is no common factor, you need to take 1 outside so that the balance is the same number, 2y minus 3 equal to 0. Now you can see the common, here 2y minus 3, they are common terms, so take that as common now, 2y minus 3, the remaining numbers are 2y and here plus 1 equal to 0. Now we need to separately, you want to equate to 0, so that 2y minus 3 equal to 0 and 2y plus 1 equal to 0, and from here you are getting 2y equal to 3 and here 2y equal to minus 1. So from this what is the value of y? Y is equal to 3 by 2 and here y equal to minus 1 by 2. So thus we got the two zeros of the given polynomial, y equal to 3 by 2 and y equal to minus 1 by 2. Now after getting the two zeros, what is our question? Verify the relationship between the zeros and coefficients. Already you studied the relationship between zeros as coefficients. What are they? Alpha plus beta equal to minus b by a and alpha beta equal to c by a. So that relation we are going to verify using this zeros, whether it comes true or not. So for that, let us first find sum of the zeros and product of the zeros. So first I am going to verify sum of the zeros. To verify sum of the zeros. Okay, yes. So what are the zeros here? 3 by 2 and minus 1 by 2. So we can take the 0 as first 0 as alpha 3 by 2 and beta the second 0 as minus 1 by 2. Now when I find the sum of the zeros, what happened? Alpha plus beta is equal to 3 by 2 plus minus 1 by 2. What is the answer for this? You can see the denominators are same, so we can add the numerators. 3 plus minus 1, that is 3 minus 1, that is equal to 2. So 2 by 2 equal to 1. So when you find out the sum of the zeros, we got it is equal to 1. Now we can verify this sum of the zero using the relation what we studied. You know that by the relation we know alpha plus beta is equal to minus b by a. And our polynomial, you see the question, what is the polynomial? 4y square minus 4y minus 3. So here what is the a? Value 4. B is minus 4 and C is minus 3. So put the relation minus b by a and find out the answer. So that is equal to minus b. What is b here? Minus 4. So minus of minus 4 by a. What is the value of a? It is also equal to 4. So minus of minus 4 by 4 using this relation, that is minus of minus 4 is 4 by 4, which is equal to 1. So what we get here, when you find the sum of the zeros directly, you got the answer 1, and when you use the relation also, you are getting the answer 1. So what does it mean? This means the sum of the zeros using this relation is verified. So you can write, hence alpha plus beta, we got it is true minus b by a. Therefore it is verified. So the relation for sum of the zeros is verified. Now the similar way we are going to check the second relation, that is product of the zeros. So product of the zeros, So first we can do by direct method. First 0, what is the first 0? 3 by 2. And the second 0 is minus 1 by 2. So what happens when you multiply this? 3 by 2 into minus 1 by 2. So 3 by 2 into minus 1 by 2, you want to multiply the numerator and multiply the denominator. So that is equal to 3 into minus 1, minus 3 by 2 into 2, 4. So product of the zeros we got minus 3 by 4. Now we are using the relation. We know what is the relation for product of zeros? That is alpha beta equal to C by A. Understand? So when you use this C by A, what answer you are getting? From our polynomial, what is C? It is minus 3. And what is A? It is equal to 4. So that you are getting minus 3 by 4. The same answer as you do previously. So thus we can verify that product of the zeros alpha beta equal to C by A. So therefore alpha beta equal to C by A, it is verified. So all of you understood this example. So practice well and clear the concept. Yes, now see the second example here. Verify the relationship between zeros and coefficients of the quadratic polynomial x square minus 8. So this is a quadratic polynomial and we need to find the two zeros. A quadratic polynomial is always having two zeros. So first we need to find the zeros, then we can verify the relation. Okay. So given, write the solution. Given polynomial is x square minus 8. So in this polynomial you see children, here the x square term is available and the constant term is available, but the x term is not there. So when this type of quadratic polynomial is coming with any one term is absent, you need not apply the method of splitting the middle term. Instead we can do the factorization method or common factor method to find the zeros. So here because one term is not there, we are not going to splitting the middle term method. Okay. So how to write this? We can write this as x square minus 8. To find the zeros, we are equating this to 0. So x square minus 8 equal to 0, and here we get x square is equal to 8, and when from x square we can find x by the square root of 8, that is x is equal to plus or minus root of 8. Okay, and now root of 8 we can write as plus or minus 4 into 2. 8 can be written as 4 into 2. And what is the square root of 4? 2. And root 2 will come, so that plus or minus 2 root 2. Understand? So we need not find the splitting the middle term method, and you can do directly by our simplification, so that we got x is equal to plus or minus 2 into root 2. That are the two zeros of this given quadratic polynomial. Now we are going to do the verification. So first we are going to find out sum of zeros. Okay, so sum of zeros, what are the two zeros here? Plus or minus means it is 2 root 2 is one root and minus 2 root 2 is the second root. So sum of zeros, when you are going to find 2 root 2 plus minus 2 root 2. Okay, the two zeros I have added now. So this is equal to 2 root 2 plus into minus is minus 2 root 2. You know the same term different sign, so it is cancelled, we got 0. So sum of the zeros we got equal to 0. Now to verify we are going to use the relation. So what is the relation we are having? When two roots are, we are taking alpha and beta. Alpha plus beta equal to minus b by a. So that is equal to, yes. Now to verify the zeros using this relation, you see here our polynomial is x square minus 8. So now you want to find out what are those coefficients a, b and c. From here you see x square minus 8. What is the value of a? Coefficient is, x square coefficient is 1. And here what is the value of b? Because the b term is absent, the x term is absent, the coefficient of x is equal to 0. Understand? And now the constant term c is minus 8. So this you want to note this carefully for verifying the zeros. When to verify the relation using this b minus b by a, you should be thorough with what is a, b and c. So after confirming these three values, you can check the relation using the formula minus b by a. So what is the answer? Minus b is equal to 0. So minus 0 by a is 1. You know that 0 by any number is 0. So it is equal to 0. Now you see, when you added the two zeros, we got 0, and when you did by the relation, you got the same answer. That means the relation is verified. Therefore, alpha plus beta equal to minus b by a is verified. We are going to verify the product of zeros using the relation. So here your polynomial is x square minus 8. So what two zeros we got? 2 root 2 and minus 2 root 2 are our two zeros of the polynomial. So first we can do the product by our direct method. Product of zeros equal to, we need to multiply the two zeros. So 2 root 2 into minus 2 root 2. So what is the answer? 2 into minus 2. So minus 2 into 2 4, and root 2 into root 2 is 2. So minus 4 into 2, that is minus 8 is the product of the two zeros. Now we are going to verify by the relation. We know what is alpha beta. We know alpha beta is equal to c by a. So now c, what is the term c? C is minus 8 and a is equal to 1. So that is equal to minus 8 by 1. What is minus 8 by 1? It is minus 8. So what you can verify here? This first answer minus 8, and using the relation also we got minus 8. Therefore product of the zeros is also verified. Therefore alpha beta equal to c by a. This relation is verified. So in your textbook related examples are there. All of you should practice those examples and very clearly understand the meaning of the problem. Now the third question here, verify the relationship between the zeros and coefficients of 3p square plus 9p. So in this polynomial also you can see one term is not there. Here the constant term is not there. So you need not go for splitting the middle term method. You can do and find the zeros by factorization method. So here solution, first we are going to find the zeros of this quadratic polynomial. So to find the zeros, what we will do? Equate the polynomial to 0. So 3p square plus 9p equal to 0. Now you can see here we can find the zeros by factorization taking the common factor of the two terms. Here 3 and 9 from 3 is the common factor, and p square p from p is the common factor. So you can take the common factor of this expression. 3p square plus 9p is the common factor. So here we have p remaining, and here 3 into 3 9. So p plus 3 equal to 0. Now we can equate this separate factors separately to 0. That implies 3p equal to 0, p plus 3 equal to 0. 3p is equal to 0, p plus 3 equal to 0. So what is the final answer? We are getting p equal to 0 by 3, that is 0, and p equal to minus 3. Thus we got the two zeros of the polynomial, p equal to 0 and p equal to minus 3. Now we need to verify the relation between zeros and coefficients. So first we need to verify sum of zeros. To verify sum of zeros, Okay, so first sum of the zeros equal to, yes, what are the zeros we have? 0 and minus 3. So that when you add 0 plus minus 3, what is the sum? Equal to minus 3. Okay, now we are using the relation. If alpha and beta are the two zeros, alpha plus beta is equal to minus b by a, that is minus b by a. So when you check the relation, you need to identify the coefficients, what is a, b and c. You know that our polynomial is 3p square plus 9p. So what is a here? The coefficient of p square 3. B is the coefficient of p, that is 9. The constant term is absent, so it is equal to 0. So whenever you are verifying the relation, you need to write this separately to make your answer easy to solve. So now you can write minus b by a. Minus, what is b? 9. A 3. What is minus 9 by 3? 3 and 9 we can cancel, so that minus 3. Now you see children, when you find the sum of the zeros, you got minus 3. Using the relation also you got minus 3. Therefore sum of the zeros is verified using the relation. Therefore alpha plus beta equal to minus b by a. This relation is verified. Now the similar way we are going to see the verification of product of zeros. So to verify the product of zeros, we want to multiply the two zeros. Okay, to verify product of zeros. Okay, what is the product of the two zeros? Product of zeros equal to, yes, our first 0 is 0 and the second one is minus 3. So 0 into minus 3. 0 into any number, you know it is equal to 0. So product also you got 0 here. Now we can verify using the relation. What is the relation for product of zeros? We know alpha beta equal to c by a. Now what is the value of c? 0. What is the value of a? 3. So 0 by 3 is again 0. We got the same answers. Therefore the product of the zeros alpha beta equal to c by a is verified. So all of you practice these type of similar questions from your textbook and understand the concept very well. Now we are going to see how to form a quadratic polynomial when we know the two zeros alpha and beta of the polynomial. So from this, if alpha and beta are given as the two zeros of the polynomial, how to form the polynomial we are going to see. So alpha and beta are the zeros. Sum of the zeros, sum of zeros alpha plus beta, product of zeros alpha beta. So when you are given the two zeros of the polynomial and we are finding the sum of the zeros, product of the zeros, if we are having this answers, we can form the quadratic polynomial. The quadratic polynomial whose general form is the quadratic polynomial we can form using the sum of the zeros and product of the zeros as k into, this is the general form of a quadratic polynomial when you know the sum of the zeros and product of the zeros, that is k into x square minus alpha plus beta into x. This is the x square term, this is the x term plus alpha beta. So for any question, when you are know the two zeros, and if you can find the sum of the zeros, product of the zeros, the quadratic polynomial is k into x square minus alpha plus beta into x plus alpha beta, where this k is a constant. That is, it is a real number. It can take any value. When the k is varying, the polynomial is also varying. So if you are asked to find in the question a quadratic polynomial, one quadratic polynomial, then we can assume k is equal to 1. So our general form is x square, that is when k equal to 1. You are asked to find one quadratic polynomial from the question. When the zeros are given, the general form will become x square minus alpha plus beta into x plus alpha beta. So if you are asked to find more polynomials, we can give different values for k and we will get different polynomials. So in your exercise also there is a question to find the quadratic polynomial for the given zeros, so that you can assume k equal to 1 and use this formula for finding the quadratic polynomial. So now we can see some examples and form the quadratic polynomial when the zeros are given. Yes, now we can see the first example, how to form a quadratic polynomial. The question is, form a quadratic polynomial whose zeros are 2 root 2 and minus root 2. So what is the meaning of this question? We are given a quadratic polynomial whose zeros, so there are two zeros here. They are, one zero is 2 root 2 and the other zero is minus root 2, and here read the question carefully, form a quadratic polynomial. So a quadratic polynomial means you want to form only one polynomial. So that, as I told previously, in the general form we are having the quadratic polynomial. What is the form of quadratic polynomial? When its zeros are given, the quadratic polynomial is of the form k into x square minus alpha plus beta into x plus alpha beta. So because in this question it is asked only one polynomial, we need not consider this k, and so our quadratic polynomial for this question becomes x square minus alpha plus beta into x plus alpha beta, because a polynomial, so that no need of assuming k. So for this you are going to find what is the polynomial, so that what are the things we require, children? Because it is given zeros. Zeros are 2 root 2 and minus root 2. You know that how we are assuming the zeros. Let the first zero we want to take as alpha, that is 2 root 2, and the second zero we want to take beta minus root 2. Okay, so assume the given two zeros as alpha and beta. Now in order to form the polynomial, what are the things we need? We need sum of the roots alpha plus beta and product of the roots alpha beta. So the next thing is you want to find out what are the values of alpha plus beta and alpha beta. So alpha plus beta means you want to add these two answers. So 2 root 2 minus root 2. Okay, what is 2 root 2 minus root 2? Here 2 root 2 minus root 2 means it is 1 root 2. So when you subtract this, root 2 is common, 2 minus 1. So that what is the answer? 2 minus 1 is 1, that is equal to root 2. So thus we got the sum of the zeros alpha plus beta equal to root 2. Now we can find what is alpha beta. So alpha beta equal to, multiply the two zeros, 2 root 2 into minus root 2. Okay, multiply. When you multiply 2 into root 2 into root 2, that is minus 2 into 2. Root 2 into root 2 becomes 2. So 2 into 2, that is minus 4. So now you got alpha plus beta value is root 2 and alpha beta value is minus 4. Now you can substitute these values in our general form of the polynomial. So what you get? Therefore the quadratic polynomial is, yes, first term is x square minus alpha plus beta. What is the value of alpha plus beta? Root 2. So in the place of alpha plus beta we want to put root 2. So it is minus root 2 into x plus alpha beta. What is the value of alpha beta? It is minus 4. So here plus alpha beta. So plus into this minus 4. So it becomes minus 4. Okay, plus and minus will become minus, so that this is the required polynomial for the given two zeros. Okay, so when the two zeros of a polynomial are given, you want to find the sum of the zeros, product of the zeros, and apply in this general form to get the required polynomial. And you know children, because here it is given find a quadratic polynomial, we are not taking that k and simply removing the k and writing the general form like this. Okay, yes. Now one more question from this. Find a quadratic polynomial given the sum and product of its zeros are minus 1 by 4 and 1 by 4 respectively. So in this question is different from the previous one, because in this question the zeros are given. This is the first zero alpha, this is the second zero beta, but here it is given the sum and product. Okay, sum and product of zeros are minus 1 by 4 and 1 by 4 respectively. So respectively means the first sum you want to consider as the first value, that is sum of the zeros minus 1 by 4 and product of the zeros is the second value 1 by 4. In that order only you want to assume the values. Sum is minus 1 by 4, product is 1 by 4. Okay, so when you know that alpha and beta are the two zeros, how to write the sum? Alpha plus beta, and product is alpha beta. So how you can write? So you understand the difference here. The two zeros are given, but here sum and product are given, so that you can write directly given sum is alpha plus beta. Okay, before that you can write let alpha and beta are the two zeros. Okay, so we can write sum of the zeros alpha plus beta is given minus 1 by 4 and product, this is the product of the zeros, so alpha beta equal to 1 by 4. Okay, so sum of the zeros given, product of the zeros given, so therefore what is the general form of the quadratic polynomial? The quadratic polynomial is, here also you see in the question, find a quadratic polynomial, a. So one quadratic polynomial, so no need of writing the k, you can just write the general form as x square minus alpha plus beta into x plus alpha beta. Now put the values here. This implies x square minus alpha plus beta. Here you see alpha plus beta value is minus 1 by 4. So this minus and the minus here will become plus. Alpha plus beta 1 by 4 x plus alpha beta. What is the value of alpha beta? 1 by 4. So you can put alpha beta 1 by 4. So this is the answer for the given sum and product of zeros given. So that is the required quadratic polynomial. So you are having similar problems from the textbook. Practice all those problems and do the homework also. Complete the exercise problems and very well understand the concept.
All of you complete the homework from exercise 2.2 questions 1 and 2. Complete your notes and complete the homework also by time. Meet you in the next video class. Thank you.